Okay. Bonjour tout le monde, and welcome to this session. And I'll show you to make the session to make sure you're on the right one. Just a little bit of click here now. So just one moment. It's coming. There you go. Yeah. So my name is Serge. I'm sharing this session. It's one of the general session, atmosphere, community service, and education. We have 5 presentation schedule. We're missing someone at some point, but we'll see if this person show up. But the first speaker will be Gordon Burr. And then I will stop sharing so that Gordon can actually put his presentation and start his presentation. Go ahead, Gordon.
Okay.
All good. Thank you.
Good. Okay. Okay. Hi. My name is Gordon Burr. I'm an adjunct professor in the School of Information Studies at McGill University. I'm going to speak today about the case of DRAW, or how a weather data rescue project became a prehistoric science archive by engaging student communities. Whoops. Bit of the background of DRAW. We were created in 2015 as an interdisciplinary research project at McGill with academics from science and arts and archivists. The Data Rescue Archives and Weather Project has been using crowdsourcing to transcribe on our custom-built website millions of historical weather observations housed in handwritten ledgers of the McGill Observatory found in the archives of the university. Citizen scientists contribute their skills as interpreters and problem solvers when transcribing data. DRAW also acts as a participatory science archive working to engage the community through its social media presence and local crowdsourcing. A key element of the project focuses on DRAW as a pedagogical tool for junior colleges and in university courses. By 2023, DRAW had transcribed over 1.5 million data points with the help of volunteer and citizen scientists. In addition to the transcription of weather observations, DRAW has expanded its scope to include outreach and educators' corner with a DRAW blog, lesson plans, additional weather-related sources to provide avenues for outreach in which volunteers, citizen scientists, and others are introduced to DRAW and the DRAW team, as well as related weather topics. Crowdsourcing through citizen scientists transcribing the weather observations is an important aspect of the DRAW project. The About the DRAW project webpage highlights the value of citizen science and crowdsourcing, in which the page exclaims, "We need your help." The About page lets citizen scientists know it will take upward of 45,000 hours of work for a single person to transcribe all the information contained in the ledgers, and by becoming a citizen scientist, you will help researchers in the quest to better understand our past climate. In terms of the community engagement, making sense of the information using citizen science and participatory archives, in the participatory science level, DRAW citizen scientists ask about recorded casual phenomena or weather events such as winter storms. Citizen scientists then added related historical information from other sources, or they work with one of their instructors to define a new problem. The participatory science level leads to the bringing together of the weather, or natural sciences, and history, social sciences, that augment the value of the transcribed data. Though the DRAW project began as a crowdsourcing outreach project, it has evolved considerably since then. The archivist paradigm shift, clearly stated by Terry Cook in 2013, from a custodial bent to an active participant role, working in collaboration with communities, to jointly engage in the archival process, was a clear call for rethinking, of the archival profession. The lesson of these traditional barriers between archivists and their audiences have helped move the archival profession into a participatory archives mode. Indeed, the rise of these archives based on Web 2.2 technology, social media, and the increasing amount of digital collections has risen archivists with targeting user engagement and increasing access to their collections as a new mantra. Archives have used participatory archives in various forms, including social tagging, commenting, and crowdsource models like Draw, which is a wonderful opportunity for us to work with. Now, linking educators' corner resources to research narratives. The Draw blog offers a way of engaging people with the project, adding to climate literacy, and celebrating both the volunteers and the project's milestones. In 2018, the Draw team began to develop the Educator's Corner as an interactive space for teachers and students to use in the classroom. The materials are designed to supplement curriculum objectives in various subjects while providing hands-on experience with data analysis and furthering students' knowledge and understanding of historical weather and its scientific and social impacts. Draw has become an important resource, not just for rescuing historical weather data, but also in outreach and education for both CEGEP and university students for undergraduate courses and graduate courses in geography and archival studies, including the Convocation Day Weather Project, which is linked to participatory archives concept. Draw content, blogs, newsletters, webinars. Okay, who are the Draw crowdsourcing contributors? Well, the Draw audience is made up of two types of public users, occasional and super data rescue contributors. This is a norm for many crowdsourcing projects. Many of the occasional users are students working on data rescue projects tied to educational settings. The design of the project has been driven by our interaction with this diverse crowd and the teacher's requirements for sound pedagogy. The science research element of the project places great emphasis on the testing and validation of the data for weather research purposes. The archival element seeks exploitation of these records for the creation of a meaningful researcher experience. This emphasis on both user and community engagement is the most significant upside of participatory archival projects. By relying on volunteers and community members to help with the description and processing of records, participatory archives engage the wider community, and a mutually beneficial exchange happens, providing for greater relevance for archives. The narrative becomes both more complex and more in tune with the communities the records are about or created by. As citizen scientists become more engaged in the DRAW project, some move towards a participatory science or archival role. Knowledge is exchanged more frequently and extensively when citizen scientists ask more in-depth questions about the historical context and impact of the weather. The participants take part in the creation of online archive experience tied to a researcher-generated narrative based on archival sources created directly by the user. Everyone who participates in DRAW makes the records they create available for weather research, but also keeps under their username any data they have rescued and can contribute to our content via our website using their own data. Now, I'm talking a bit about the Convocation Day project involving McGill School of Information Studies and students there. From 2021 on, in courses in the McGill School of Information Studies, students were asked to do background research on participatory archives, transcribe scientific weather data on the DRAW website, as well as to produce a blog entry with a related Instagram message tied to a weather-related theme. Specific lesson plans are configured to provide students with a participatory archives experience in an online practice-based manner. The goal in teaching these archival courses was to provide the students the opportunity to work with real archival records with a focus on creating actual archival products directly useful in the current archival workplace, such as blogs and social media posts. The learning objectives for this work were to understand the rationale between the creation of participatory archival institutions, the influence from community archives and digital technologies on their creation, and how the community engagement approach of DRAW has impacted the traditional role of archivists. The emphasis was centered on the use of DRAW as more than a teaching tool, but as a unique, self-made participatory archival online experience. This is the outreach products include a blog entry and related Instagram post. Here's an example of a blog entry. It showcases the material, highlights the data, and provides an experience on how to engage communities. Analysis of weather for the convocation date was supplied by the students based on the data viewed and linked to a narrative of their choosing. If the students wish to do so, they can submit their work for inclusion in a DRAW blog. The blog shown here, created by McGill School of Information Studies students Emilia Keenan, Chloe Motzi, Vienna Enright, Alicia Ash Briella, was the story of Dr. James Grant, who was receiving a copy of his medical degree to replace the one he had lost during his sinking in 14 minutes of the Empress of Ireland in 1914 in the St. Lawrence River, with the loss of more than 1,000 passengers and crew. Grant barely made it to safety. Once ashore, he started treating the survivors for their injuries. And here's a little story about it. And here's the related Instagram post. The Instagram posts, always smaller, much more photo oriented or image oriented, was meant to advertise the blog, try and capture the participants' attention, and get them interested in seeing more. The hook here is a story, a trip from Quebec City to Liverpool, a foggy night, and a borrowed pair of pants. Set the scene for Dr. Grant's heroic call to action. So if you read the full blog post, the link is here. You'll get the entire story. Okay, and that's Dr. Grant on the bottom side treating patients who are injured in the sinking of the vessel. So here's some of the lessons we learned, sort of the basic requirements for a meaningful experience for students. First, the website basics. You've got to have a user-centered health features with online training on the data rescue process via webinars and FAQs. That's absolutely necessary. We need to do testing to ensure a user-friendly GUI. That was the key here. We did many tests with students in various geography and the School of Information Studies to test out our website. The active social media program with policies in place, you need that. The program what we created was a bootstrap operation, borrowing from current university policies with the help of contract staff and volunteers for the School of Information Studies, once the money ran out, of course. The education basics. Have to frame teaching and research questions to meet data rescue needs via appropriate lesson plans based on the pedagogical levels of the students and subject content being taught. The selection of appropriate weather themes is also needed to help identify the impact of the weather on society. Things like disruptive weather events, fire and smoke, food and the weather are part of the thematic research guide as suggestions in our Educator's Corner. The access to additional primary and secondary online sources is also a requirement beyond Educator's Corner to provide context for the work being created. Newspapers, digital photo collections at Bank and Macquarie Museum. The conclusion, well, DRAW has a participatory archive element that places great emphasis on user interaction with the data they input and the creation of new knowledge in such entities as blogs and newsletters. Users are encouraged to construct narratives by using DRAW data from their personalized data accounts and then linking these to other weather resources to create their own research project agendas and blog entries on their experiences. The weather data rescue is also available on a collective level for scientific research purposes. Thank you very much for your time. Are there any questions?
Thank you, Gordon. I have a question for you before we go to. I have to see on the event movie to see if there is a question. But when you talk about the video, how to draw a video, is it how do you have access to it?
You can just click on our. It's here, and there's a link, and it's on our website.
It's on the website. So if you do how to draw, you should be able to find it.
Oh yeah, you'll get it. You should get it.
Okay, that's good. Thank you. Okay. So I'll check on the event movie if there is some question.
Okay.
Yes, there is one. So Gordon, is the focus on information studies for the participant one or particular or of programmatic nature?
Particular programmatic?
So is the focus on information studies for the participant one of practical or of programmatic nature?
Well, it's kind of it's practical in the sense that I want students to have the experience of creating archival records and then seeing how those records can be communicated to the wider community everywhere. And draw presents a really wonderful opportunity to do this, especially in the archival side, because archives have been traditionally a place where user communities usually don't do it online. They're usually, you have to line up, you have to sign in, you have to, all this very kind of barriers. Custodial aspect of archives has been really important over the years, and it still is. But I mean, it's just with online materials, you have to have different approaches. And I'm trying to show the students how to use online systems to really engage audiences and get people to come and use archives. It's basically, it's an archival, I'm teaching the archival area, information studies.
Okay, this is a very interesting project. I don't have other question, and there is maybe 30 seconds left, really, before we go to the next one. So I guess thank you,
Okay.
Gordon. A very good presentation. We might have time actually if the person doesn't show up to have further discussion. We'll see.
Okay. I'll be
So
around.
okay, so we're gonna go to the next one. There's a
Do
lot
I
of
have to, do I have to unshare my screen now?
yeah, you have to share your screen. Yeah.
Okay.
Okay, so the next one is from Robyn Dyck, and it's MSc COMET Applied Numerical Weather Prediction course, investing in the meteorologists of today, preparing for the impact and probability based forecasting on the future. So I'll give you the screen, Robyn, and you can start.
All right. Well, thank you very much, Serge, and thank you, Gord. That sounds like an interesting project as a forecaster. Improving odds is always a great topic for us. So today, my name is Robyn Dyck. I'm a meteorologist with the Meteorological Services of Canada in the Training and Career Development Division. I also moonlight on occasion as an operational forecaster with Prediction Services. So I'm here today to talk about I'm a co-developer and co-facilitator of the MSc COMET Applied Numerical Weather Prediction course, Confidence in Uncertainty. So I'm going to talk about how we are investing in the meteorologists of today and preparing for the impact and probability-based forecasting of the future. So I want to for sure acknowledge there was a lot of people involved in this project. So my co-developers and co-facilitators are named on this slide. So before I get into the details of the course, I wanted to give some background. So a training needs survey was conducted in the summer of 2020, and that was with Prediction Services Division of Meteorological Services of Canada, as well as some other specialized like A&P, the Analysis and Prognosis Department of our modeling agency, CCMEP. So they were asked to self-assess their NWP knowledge, so from 1 to 4. So 1 being novice and 4 being an expert. So forecasters rated themselves as having better knowledge in the deterministic NWP, and gaps did exist in the EPS, the ensemble forecast system side of things. Forecasters did express there was a lot of interest in learning EPS, and especially learning EPS for communicating uncertainty. So this course was aiming to address that. And this is, of course, all a part of the much bigger movement towards the IBFWS, so the impact-based forecast and warning services that a lot of the weather agencies are moving more towards, meeting our clients where they need us to be. So the synchronous course, we had 2 rounds, and they were in the fall of 2022 and winter of 2023. There were 14 different weather agencies that participated, so included Papua New Guinea, UAE, Cameroon, Indonesia, UK, Croatia, Latvia, Sweden, and then of course the US and Canada. So it was over 12 weeks. There were 6 sessions, so it was bi-weekly sessions. The course consisted of prerequisite readings, synchronous lecture discussions, asynchronous forecast exercises, and the course allowed students to explore how different model constructions and schemes can manifest in the forecast, and how to interpret the resulting forecast output, including both the DPS, the deterministic, and the EPS, ensemble prediction system information. So the unit topics included resolution, post-processing, parameterization, distribution characteristics, probabilistic weather scenarios, and then a final synthesis. Pre and post tests were completed to measure knowledge retention, and we did do feedback surveys after each synchronous session to enable us to improve the next session. This was all completed virtually on Zoom and was recorded to ensure that folks could revisit material, and was all used in the repackaging of the asynchronous online course. So the English version of the asynchronous course is now all available on the COMET program's MET-Ed site. Unit 1 was first published in November of 2023, and Unit 6 was published in February 2024. The online course includes all materials, including the video recordings of lectures, discussions. It's all been condensed into a comprehensive asynchronous format to be used in a self-paced manner by any forecaster or student. There's a complimentary instructor's guide, which suggests ideal material pacing, additional discussion prompts for those who can investigate in more depth and can create cohorts within, say, their own weather agencies, their own offices or classrooms, wherever that may be. Units 1 to 5 are also now available in French, and Unit 6 is coming soon. So I want to highlight some of the aspects of the course that stood out as successes from both the facilitators and the learners' perspectives. So first of all, the framework, it came out as running the course multiple times. It came to fruition from the development team, just brainstorming what were the important questions that we wanted participants to use in their own self-assessment of their individual knowledge gaps to drive their own learning. So these are questions that they can refer back to over and over again as they incorporate new models or new products into their forecasting process. The intent of this was not just to guide the course itself, but also to give participants that constant reminder and something tangible for them to take back with them into operations on the desk and to practice the skills that they learned. Part of this course also allowed us to do a deep dive into modeling in ways that forecasters don't have the time to do on the desk. So one topic that was greatly appreciated by participants was looking more into the surface land masks and water masks and how the different models represent this differently and how it's different from reality. So they were able to investigate down to the pixel level, looking at differences in model resolution and surface representation. So this is an image of southern Manitoba, and it's showing two different model surface parameterizations or schemes. So this is the GDPS and the GEFS, having different resolutions and different surface representations. So this is very important in southern Manitoba. In the spring, when the land surface heats faster than the water, any wind direction that's offshore can significantly impact daytime high temperatures. And in the fall, when even into the winter, when the water is still warm, but aloft temperatures can be quite cool, that can lead to streamer development and significant snowfall accumulations downstream of the lakes. These are all areas where forecasters can add value by just understanding the internal workings of the model. In Unit 4, we covered distribution characteristics. We used the publicly available version of DESI, so that's the dynamic ensemble-based scenario for IDSS, and we used it to interrogate the entire ensemble data set by looking efficiently at individual members. So this is where we're trying to guide students beyond using the standard charts and beyond using, say, a mean as just another deterministic member, to instead understand and leverage the entire data set. So by looking at, say, for example, this is a histogram or a PDF, a probability distribution, probability density curve function, and looking at not just the mean, but also medians, modes, and knowing and understanding when you should be using one over the other. So for this example, it's showing you that the JEF's 6-hour QPF data has a positively skewed distribution. So understanding that the outliers will impact your mean, making the median more useful. And another example showing that the 6-hour QPF data is a gamma distribution, and again showing that the mean is not a good representative of this data set. In Unit 5, we covered cluster analysis, and this was in Unit 5 was the probabilistic weather scenarios unit. So this is a tool that's used in the NWS. It's fairly new to the MSc. As an operational forecaster, there's so much data to review when making decisions, and sometimes there's very little time to review it all. So charts like this not only summarize all the data or all the members within one ensemble, but the WPC cluster analysis uses empirical orthogonal functions and principal components to summarize the members of all the three major weather agencies ensembles. So the ECMWF, the European model, has 50 members. The GEFS, the American ensemble, has 30 members, and the JEPS, the 20-member Canadian ensemble. So together, that's 100 members, and you can look at your variable of interest. So for this example, I'm showing the 500 millibar heights. So this displays the spread of the members that fall into the top two EOFs and the mean heights. On the right, this is shown in a phase space diagram with PC1 on the x-axis and PC2 on the y-axis. The origin of the phase space diagram is essentially representing the mean of the 500 millibar heights, which is shown in the EOFs on the left. So a positive PC2 and a positive PC1 would fall into the top right quadrant, meaning that those members look most like the two scenarios on the left. So the spatial distribution of the 500 millibar trough and ridge would actually be slower than the mean, or a positive PC1. And the magnitude of the trough would likely be more deeper than the mean, positive PC2. So most of the members of the ECMWF, which are shown in blue in the top right quadrant, they fall into that positive PC1, positive PC2 area. Also on this phase space diagram, you can see there's a little blue circle and a little blue star. That is also the ECMWF deterministic and the mean of their ensemble. So in contrast, the JEFS, which is in yellow, is more negative PC1 and positive PC2, while the JEPS, which is in red, is more the negative PC1 and negative PC2. So negative essentially means the opposite of those two EOFs on the left side of the chart. So the most important aspect of this that we emphasize for operational forecasters is that this statistical information has associated physical and meteorological meaning. So their job is to interpret this data, these numbers, and apply them to the phenomenological scenario of the day or whatever is at hand. And then confidently, in their probabilistic communication, they use that to talk about the most likely scenarios and the most likely impacts to their clients. Whew, that's the heaviest slide, I promise. So now I'll finish up. So this is just a chart of some of the numbers of sessions per unit since publishing. So this is just an example of Unit 1 was published November 2023, and then
Robyn.
Unit 6 was published in February 2022. Yeah, 2 minutes. I got it.
No. You still have 5 minutes.
Okay.
It was just the 5-minute symbol.
Yeah, I saw that. Thank you very much.
Okay.
So basically, this is just showing that we have lots of people using it. Obviously, more of Unit 1 compared to Unit 6, since they were published at different times. Some examples of some of the users of this training. The top weather agencies are the NWS in the States, and then BOM from Australia, Bureau of Meteorology, and then the MSc, of course. And just for example, the Americans use this quite a bit. And so some of the different top users that use it, not only forecasters, but also colleges, universities, weather enthusiasts. And then they had another category, which I wasn't sure exactly what that is, but all the units have been rated because they're all online, so people can leave comments and rate them, and they've all received anywhere between 4 to 4.5 out of 5 stars. So thanks to all the contributors, and of course, there's lots of participants, especially in the synchronous courses. We couldn't have had the asynchronous without them, so I do thank them very much for all their help. This was a long project in the making, starting in 2020 when we were discussing it, and then the 2022 and 2023 executing the synchronous, and then the 2023, 2024 doing the asynchronous course. So it was a long time in the making. But that's all for me. Thank you very much for attending and listening, and back to you, Serge.
Thank you, Robyn. Yeah, and just to remind, this little symbol here means you still have 5 minutes left. So all people know when they're gonna see that too. So that's great. So I'm gonna go on the Event Mobi site to see if there's a question for you. There is none for now. So I'm still the monitor. If someone has a question for you. I wish I could have focused a little bit more on the presentation, but it's difficult for a session chairperson because it's you have to go from one place to the other. So I'm just going to check again in the Event Mobi. No, there's no question.
Sounds good. That means I was perfectly clear.
You were perfectly clear. Yeah, but anyway, like I mentioned to in the chat, and I mentioned to the participant too, we have 5 presentation in this session. So that means we have a 15-minute left at the end because usually it's a six presentation. So we have a 15-minute left that we could go general question. So if you don't have the question yet, just put it in the QA and then specifically say which person you want to talk to, and then we'll try to cover as much question as much question that we can. Thank you. I'll just check because there's still some time. Kuyo. Yes, great presentation, Robyn. Is there a push from the training division to get development of EPS tools accomplished and to forecaster? There is very little EPS available to forecaster within the MSC. A second question is there a training plan too on how to communicate this analysis to clients? You have 30 seconds left.
Sure. Yeah, I mean, I'm not in charge of tools. So the tool part is probably on the CCMEP front. Our current tool is Nino, but forecasters do use a lot of web-based, especially for ensemble data. And in this course, we did use, as I showed, we used a lot of web-based stuff. So NWS, private websites, or not private, but publicly available websites, WeatherBell, Pivotal Weather. Yes, you're right. Tools are very important to be able to efficiently visualize ensemble data, which is what I showed with the WPC cluster analysis. We have, I mean, this was also, this training also covered sort of how to communicate this to a client. In Unit 6, the synthesis portion, there are specific clients as it's an example of how to use all this information that you've learned during the course, how to use it during a case study. So there is a case study that has some hypothetical clients. So you would go through that. However, this, as I said in the beginning, this is a stepping stone to more of the IBF world. So we do have plans on doing more of the impact-based forecasting and communication for sure.
Okay, thank you very much. So we're going to go to the next presentation, which is CAMNI, the new Canadian Weather Radar Network, from project to operation. So Qian, I'll stop sharing and then you can start sharing.
Hey, thank you. All right. I hope you can see my screen.
Yeah, everything is perfect.
Perfect. Thank you, Serge. Yeah, my name is Qian Li. I'm the Science Liaison Officer within the Canadian Weather Radar Replacement Program. In the past few years, now I'm transitioning to the National Radar Operations, doing similar role, engaging the radar scientists and the data processing team, the radar users for the continued improvement of radar data and services. So in the past few years, I have been providing CWRP updates at CMOS. So this will be the last update because the project wrapped up in March. And then, as you all know, the CWRP has started in 2017, has undergone significant transformation. And then by the conclusion of 2023, all 33 radars have been successfully installed nationwide, with 32 currently operational. So this presentation, I will give an overview of the accomplishments in renewing the radar network, and in transitioning to operation, I will introduce hardware solution we plan to implement that will mitigate one of the major impacts of the radio frequency interference on data quality, as well as some operational challenges and the future endeavor aimed at future enhancing the effectiveness and reliability of our radar infrastructure. So I'd like to acknowledge all the co-authors and everybody that contributed to the CWRP project and also in supporting the radar operation. Just a quick recap of the replacement project. The CWRP was a 7-year infrastructure initiative aimed at modernizing Canada's weather radar system. The project involved replacing 32 outdated radar and adding 1 new site in Fort McMurray, Alberta. Also added 1 testing and training site in Egbert, Ontario. Also include, decommissioning of 28 old radar system. So the project also include updating radar software application to ensure the new radar system could continue producing accurate and reliable weather data. So yesterday, my ECCC colleague, Robyn, presented some specific improvements of the operational data products from the radar renewal. So we have been dealing with a lot of issues in the past few years, especially during the pandemic. But at the end, we have a modern network of top-notch weather radar. So this new radar delivered higher data quality, improved our ability to detect severe weather in both summer and winter. That means our weather warning will be more accurate and effective. And also we expanded our coverage, which I will show some map later on. We are now having our, scan strategy changed to 6 minutes instead of the old 10 minutes. So that's all the improvement to the old radar network. And hopefully down the road, we can improve the operational efficiency. So that's continue to monitor the cost and maintenance of the network. With the installation of the Fennel radar in BC, we have all the 33 dual polarized S-band radar there. So now all radars are owned, operated by ECCC. The key difference with the new radar network is the extension of the Doppler range from the old radars 113 kilometers to the new radars 240 kilometers. So this both increase the ability to detect severe weather and increase the overlap with neighboring radar in case of outage. In 2016, the total area of Doppler coverage is over 1.3 million square kilometers. As shown in the map, that's about 85% of Canadian are covered under Doppler range. And this map just to show the new network, the Doppler coverage has been increased to, cover 98% of a Canadian population. Also last year, we increased our scan strategy that covers 330 kilometers of a conventional reflectivity radar data. And that increased the coverage to over 99% for conventional coverage. So we also conducted an analysis to analyze population center covered by both Doppler and conventional radar range. And this table on the screen summarizes the results. Based on the definition and the data from 2021 census results, the new network provided Doppler coverage to more than 94% of Canadian population center and nearly 96% of precipitation coverage. it should be noted that there's still no radar coverage for Nunavut, the Yukon Territory, and the Northwest Territory, but there are other technologies that provide data coverage in the North area. So one of the challenges we're facing in terms of data quality is that there are multiple sites having data contamination issue due to radio frequency interference, or RFI. There are radios, as you can see on the image. The interference are stronger than the old C-band radar, mainly because of two reasons. The first one, we are the secondary license user of the S-band frequency. The second one is the new radar system come with very high power and are very sensitive than the old C-band radar. This contamination appear to be more significant in the big cities and the sites with communication tower nearby, particularly like the King radar covering GTA area, the Franktown radar covering Ottawa, and the Blainville radar covering Montreal area. So Environment Canada has developed RFI investigation process and work closely with Industry Canada to investigate a potential source of RFI. And the table on the screen provides an overview of the RFI impacts at each site, accounting for the number of radios, intensity, and persistent. And then through our user engagement, we've collected input from them regarding which site that require, mitigation for RFI. And this images on the screen shows some significant impact from RFI during, severe weather or tornadic weather situation. On the screen, there are radar image depict one of the worst single radar event, tornado events that occurred in Southern Ontario on July 24th, I think it was 2021. This is the EF2 twister caused extensive damage to multiple properties and resulted in numerous injuries. The left side of image are from the King radar, covering the GTA, showing RFI contamination along the path affected by the tornado-produced supercell. And the right side of image are from the Franktown radar, so indicating the RFI contamination along the path approximately when the tornado started developing. Also last week, on May 27, there was a tornado passing through some RFI radios at the Blainville radar in the Montreal area. So it's beginning the active start of convective season. So we have been investigating the RFI issue, and now we are come to the stage of implementing some solutions. So yeah, as I said, in the past few years, we have been working with Industry Canada that tested two hardware solutions, we call it RFI filters at the receiver side to mitigate the issue. So we tested two different filters. They both have an advantage and disadvantage. So after test at multiple sites, we concluded that we're going to use a bandpass filter. So on the image you're seeing is a filter test conducted at the Franktown radar last October. So that shows the left one is with the filter installed, and the right one is without filter. So you can see that the filter can effectively remove all the RFI contamination without damaging any of the weather signal. One consideration is how much sensitivity loss when we install the filter. So we have tested that at the site, the measured sensitivity loss after the installation of RFI filter is about 0.6 dB. At the data site, when we evaluate the data loss compared without filter and with filter, the loss is about 1 dB. Yeah, so the SNT or the scientists conducted in-depth evaluation, so they think this 1 dB loss is acceptable. And then we have installed the filter at Qian radar last month on May the 2nd. So the users are very pleased with the installation. The future plan will be to procure more of the R5 filter installed at additional 9 radar sites. So there are, in terms of other operational challenges, there are different, motivations to establish a method to monitor a weather radar. From radar network point of view, data availability is a key indicator. There are elements in the radar system which typically gently degrade over time, such as the TR limiter. And this type of degradation cannot right away leads to the failure of a radar system. So it is possible to detect trends or unusual change of by monitoring some of the parameters and then inform the radar operations of site maintenance. The new radar has a built-in test equipment and create a data set that can be analyzed and evaluated by the monitoring system. That's one thing. The other thing in terms of data quality, we work closely with radar scientists and the processing team to build a monitoring tool. And this tool will help to ensure our data system are correctly calibrated to provide accurate data, and also make sure the antenna is accurately aligned to capture precise data points, and refine the scan process to enhance the clarity and the detail of the data collected. We also address any biases in the ZDR measurement to improve data reliability. So that's something SNT has been doing in the past few years. And finally, we need to ensure that the sensitivity across the network keep consistent. Here is one example of monitoring the trends of a near radar site ZDR values.
2 minutes left, Qian.
Okay, thank you. To access potential TR limiter issue and inform radar operations for site action. So as you can see, some 3 sites, the trends are obviously different from the other radar sites. So that will bring to the radar operations and to put maintenance in place. So in terms of future work, we're gonna do, this year we'll do network-wide server and software upgrade, and also installation of the additional R5 filters at 9 additional sites. We work with our colleagues within ECCC to develop additional tools to enhance the monitoring of the radar system and optimize the scan strategy of the radar network. I believe that's my last slide. Thank you. Happy to answer any questions you have.
Yes, we have actually one question on the Event Mobi side, and I'm going to read it.
Okay.
Has there been any work to reduce noise in the velocity scans to improve their quality?
Yeah, I think our SNT folks are looking into the signal processing process and try to improve that, and including reviewing the noise in the signal processing process.
Okay, thank you. That's the timer. Okay, so I think we're gonna go back. We're gonna go to the next presentation, since we're gonna have another larger period for question, and I don't see other questions. So the next speaker, I'm just gonna switch a little bit. Okay. Thank you, King. Ching, right?
Yeah.
Okay, thank you. Okay, so voila. So we are at the fourth presentation. Chris Fogarty is going to present about the Canadian Hurricane Center forecast product improvement. So I'll stop and share, Chris, and start your presentation. Thank you.
Okay, thank you. Okay. Thank you, Serge. This presentation is kind of to give you a summary of the Canadian Hurricane Center's evolution over the last, well, we've been around for almost 40 years now. Late 1980s is when we got started. So I'll kind of run you through a little bit of history, and then the theme here is showing you how significant storm events kind of lead to these incremental changes and improvements in what we do at the center. You know, our forecasting accuracy is one, but our communication of the threats from tropical cyclones as they move into the middle latitudes. Okay, there we go. So it was back, well, almost 40 years ago now, in the mid 80s, 1985, Hurricane Gloria was a big storm that moved up the eastern seaboard of the United States, and it moved toward Canada, the remnants of the storm into eastern Canada. It did not end up being a largely impactful storm for Canada, but it certainly generated lots of uncertainty in the Canadian public and the forecasting challenges as well with this storm. But the public in general was not sure if this was going to be a bad storm like they were seeing in the news in the eastern United States. And this was back in the mid 80s when, you know, news, 24-hour news was, you know, becoming more commonplace. Weather coverage was starting to become more common in the news. So it was this event that kind of got the Hurricane Center started. And as I mentioned, you know, big events, that was kind of the start of things. And it was a couple of years later in 87, after some research that was done by forecasters here at the center to look at, you know, how often do storms of this nature move into eastern Canada? You know, what sort of time frame should we begin forecasting for them? Things like that. So that's how the Hurricane Center was brought into existence. And essentially, it's part of the regular forecast office here in Atlantic Canada. We staff the desk on an event basis. So if there's a storm moving toward Canada or the eastern US that might affect Canada, we staff the event on an overtime basis with a subset of forecasters that do regular weather prediction year round, but are trained to communicate and forecast tropical cyclones. So that's kind of how the center operates. If we just take a zoom out to a bigger picture of tropical cyclones globally, hurricanes, typhoons, whatever, here we are, eastern in the Atlantic basin. So the Canadian areas of forecast responsibility essentially outlined in this black bold contour here. So that's essentially the forecast zones for eastern Canada, the regular 24/7 weather prediction, but it's also the Canadian Hurricane Center's jurisdiction. So in that previous slide, essentially it outlined this bold red region here. So the forecast or explicit forecast zones. The CHC has this so-called response zone that was originally established back after Hurricane Gloria as a point in which if we see a storm that's expected to move toward eastern Canada or marine areas of responsibility within 3 days, 72 hours, if we see a storm prediction within this response zone, a track node. Basically, every 6 hours, these track forecast nodes are created. That's when the center will begin our forecast process. You can look at big events over the past years. There's about 170 years of hurricanes record that's been kept, and we experience a large event here in Eastern Canada every 10 to 15 years, typically, like, a Hurricane Juan type thing, a Hazel. You can see a few of them on the map here. These are ones that are big newsmakers and sort of all hands on deck when it comes to the forecasting here at the center. Now, there was quite a period of quiet conditions between Beth in 1971, major flooding event for Halifax, and Hurricane Juan in 2003. That was a big event. It struck Halifax square on Category 2 pure hurricane conditions from that particular storm. And then Fiona in 2022, much more non-hurricane looking, but in impact wise, it was very hurricane-like damage. So here's a little map, just looking back at Hurricane Juan. So Gloria was a big event in our history. Juan was a big event in the CHC's history. And back when Juan was approaching Nova Scotia, we didn't have the ability at the time to actually issue a hurricane watch or hurricane warning. We didn't have those categories in our warning system. So after the storm, we made sure that we had the ability to actually hit the button on a hurricane warning or tropical storm warning. How we handled Hurricane Juan in our forecasts were, we certainly had rainfall and wind warnings and storm surge, all of that with very, alarming numbers, very high forecast wind speeds. But, the public, there was a 30-year quiet period, right, since Hurricane Beth in the early 70s. So people were somewhat complacent, and, our system was not really maybe geared to, alert people strongly as was required. So if we were to, replay Hurricane Juan in a forecast scenario, in a hindcast, if you will, the warnings might look a little bit something like this. Sort of a perfect forecast, we would issue a hurricane warning in the red areas here. Storm surge would be, coastal zone as such along the coast, and rainfall toward the periphery. It's typical for these systems to for the rainy part of the storm to separate from the windy part. So a few other things, since Hurricane Juan back in 2003, so that's a little over 20 years ago now. There's been lots of changes in general, increased media coverage and attention to these storms, the public availability of forecast tools. So, the public and the media, anyone can see model outputs now, tracks of, hundreds of different scenarios from the ensembles and from, many deterministic model runs. So that's a big change. Social media, of course, is a big change over the last 20 years. So that, we've modified what we do with people's, general knowledge. So, when we do media interviews, we get, questions that each year are a little more specific. The public and the media, they're learning some of the nuances of these storms and how the predictions are done. And they'll be asking us about, oh, we saw, on somebody's Twitter feed, they showed a scenario that, what's the possibility of that? And those are the kind of questions that we might get during some of our media interviews. So that's more the social science side of it. If you look at the sort of the meteorological side, the NWP side as well, the computer modeling, the track skill, how much better our track forecasting for these storms, mostly just in the tropics. If you look at statistics down there, and a lot of this translates to the north as well. Back in 1992, the uncertainty for a 3-day hurricane forecast position was on the order of what's shown here in the circle. Whereas today, in the red circle, that's your typical 3-day forecast position error. So, this is markedly less. There's Florida. So, what used to be, half a state nowadays, you can, within half of the state of Florida, can narrow down a track forecast 3 days out. In terms of the intensity of these storms, usually they're given in knots. There's a roughly 10 to 15 knot wind speed category difference between hurricane category 1 or 2 or 3. The predictions were pretty much, there wasn't a lot of improvement in the intensity skill prediction up until about 2014. And since then, there has been some more improvement in these intensity predictions. But that's just one number, a category for the storm. Forecasting, of course, is much more involved than that. And certainly within their, back 20 years ago, most of the forecasting that we did was handwritten, almost purely handwritten. Whereas now, in the last 12 years, we've got a new software system. I have a few screen captures of it here. This makes our job a bit easier as a forecaster because we don't have to worry about the formatting of the bulletin. It's kind of laid out in a consistent structure, so the public and the users get to expect a certain style. And a lot of the impacts for certain wind speed strengths, the forecaster doesn't have to remember, okay, 130 kilometer per hour wind gusts, what does that typically do? The impact statements are all built into the software, so the forecaster can pick from the menus what the different impacts are likely to be. And of course, forecast error uncertainty, so the error cone, where the storm is going to go, that's prescribed by these in our software, by these little error ellipses. So when you draw out the tangents, the outer boundary of those error ellipses, you get your uncertainty cone, it's called. And the forecasters have to kind of break the job down into discrete quantities. So every 6 hours or 12 hours, we break down the wind speed forecast into these different quadrants. And we're taking into account all NWP, web-based, Nino-based, which is in our one of our internal software tools. This is Nino, our forecast production software, as well as our NWP tool. So we take all this information and assimilate it into a final track, which is done in the system, much like you see on the screen here. And we have to make a lot of our products geo-referenced these days as well. So it's not about just issuing a track forecast with an uncertainty cone on a static map. We present all this forecast data, this forecast information in geospatial format. So, this is the code level of that stuff. The forecaster doesn't have to worry about these details. They sort of fall out of those this graphical interface that you see here.
2 minutes left.
Okay. And different ways to simplify all this, forecasting for the public is to show it on a map with simple, more graphical, not so much confusing or long text products. So the in the MSC Met Service of Canada, the CHC is part of that. Our forecast regions are based on public domains, counties. Often these are counties, but we have to split that up into like a coastal zones, breakpoints they're called. So our partners in the US, the National Hurricane Center, displays the CHC's determined warnings on their public website map, which looks a bit like this. So those breakpoints go into creation of that map, which is a very visible, highly visible public product. Now this year, the Hurricane Center in Miami, and we will also be looking toward this in the future as well. to not only show this error cone and the track of the storm, but on the map as well, show the swath of impact that's likely with the storm, particularly the wind and the surge, the heavy impacts. And that's what's shown up here in red and blue. So we try to keep reminding the users, the public, that this error cone is just the uncertainty of where the center will go, not the swath of the hurricane. And in the future, we're working toward, reducing more than just a track forecast with an uncertainty. We want to show, the swath, the history of the storm. This is where it will go, and these are the sort of the areas where the rain and heaviest wind will overspread over the next coming days. So this is kind of a prototype, what you're seeing on the screen here now, inspired by a bit of, sketching it out and getting an idea on the left there.
Okay.
And I believe that's it. Oh, there's one, this final slide is just another prototype product. Well, it's going public soon, so it will be these coastal surge probabilities.
Oh, that's great. Like
Yep.
this.
Indeed.
Thank you, Chris.
Thank you.
Gonna check if there is some questions for you on the event Mobi. I do not see question yet, but if things happen like for Ching, you have a few questions, Ching. So we're gonna have time to probably to answer a few of them after the last presentation that is coming.
Yes, I'll definitely stick around.
Okay, so we're gonna go to the last presentation, which is a record-breaking wildfire smoke event over southern Ontario from 2023, June 6 to June 7. So I'll leave you the screen, Wei.
Okay, thanks. So my share. So can you see my screen now?
Not yet.
Oh.
We see you.
Oh, here. Share. So now I think you can see my screen, right?
Yes.
Yeah, okay.
Yeah.
Okay.
Just put it on presentation mode.
Yeah, okay. So, that's not the first page.
Okay, everything's
Okay.
good.
Okay. Thanks, Serge. Feels like my talk is not fit this session well, but anyways, I am going to review a record-breaking wildfire smoke event over southern Ontario from last year, June 5th to June 8th. So outline includes a short pre-event review, event summary, the weather conditions. Our focus are OSPC's forecast and the fireworks performance, followed by short risk communication during the event. Well, yesterday, a lot of firework talks. So wildfire in Canada last year was unprecedented, and so did in Quebec. So you see in early June, fires in Quebec were very active. A lot of hotspots detected by satellite over central Quebec. And also in early June, southern Ontario was very hot and dry. So especially East Ontario, Ottawa had a record-breaking high temperature, 34 degrees on June 1st. So the onset time of this fire in Quebec was much earlier, and also the intensity was much higher. So very unusual. So this shows your smoke captured by satellite on June 5th to the left, and June 6th to the right. So you see Toronto was covered, oh, not Toronto, entire Ontario, southern Ontario was covered by hazy looking sky, and the smoke traveled as far south as in New York State. So, and it lasts for a few days. So the area of impacted, duration of this event, and also the severity all contributed to this significant event. So here is the event summary. So this shows your surface observed PM from June 5th to June 7th for Antwerp on the top panel and Kingston at the bottom. So you see on June 5th afternoon, surface PM had a gradual increase, but that followed by two sharp increase. The first happened on June 6th early morning, and the second happened on June 7th early morning. And for central Ontario and part of southwest Ontario, take Toronto West as an example, and they had a similar trend, but the PM level was much weaker than East Ontario. Also, the peak PM happened in afternoon instead of in the morning. For the situational awareness, so the major operational model for smoke forecast in OSPC, we use the CMC firework model. Excuse me. The firework, three major components of firework are CMC RDPS model, the atmospheric driven model, and the GEMMAC, an online chemical model which can simulate pollutant change with changing meteorological parameters conditions, and a near real-time Canadian forest fire emission prediction system. So firework has its strengths and also limitations as well. So it's not perfect. So you will see this later. Firework is updated every 12 hours and output up to 72 hours. So the first indication of a potential significant smoke event over East Ontario from June 5th afternoon on the top panel and June 6th early morning by firework initialized on June 3rd, 12th and on. It was kind of 2 days ahead. So the weather conditions are very favorable for long-range smoke transportation. So this animation show the surface pattern with deepening and slow-moving surface low over Nova Scotia, and a quasi-stationary ridge over Hudson Bay and Northwest Ontario. So Quebec and East Ontario, they all are under the control of increasing northerly flow. And a similar pattern and 850 millibar in pink and 700 millibar in blue with dominant northerly flow. So if we look closely, you can find in the afternoon, northerly flow increased in the evening of June 5th, then dropped slightly in the afternoon of June 6th. Then increased again. So the strongest northerly flow happened from late evening of June 6th to early morning June 7th, which related to the quick PM increase. Other than the long range transportation, we also like local vertical unstable condition also needed to mix the smoke aloft down to surface. So this slide shows your the vertical profiles of Antwerp. The top panels are for June 6th from 6 that to 9 that, 12 that, and 15 that. So you see there is a shadow inversion near the surface, but it's quite elevated and stable aloft. So which means, okay, this elevated and stable can bring or makes the smoke aloft down. But because of this inversion, so the mixing will be inhibited or at least be slowed down. So the smoke will be mixed down but accumulated above inversion layer. One by early morning, so when this inversion broken and become unstable, so the accumulated smoke aloft will be mixed down quickly. So that's the time we saw the first peak p.m. on June 6 early morning, and the lower bottom pattern from June 7th early overnight to early morning. So the second peak of PM. So similar vertical profile. Also, East Ontario has a lower topography altitude than Quebec. So when smoke was transported from Quebec south into East Ontario, it's in a elevated subsiding plume. So overall, the weather pattern is favorable for smoke transportation, both horizontally and vertically. Oh my God. Okay, so now moving on to OSPC's forecast. So this slide shows you the surface PM and June 6 early morning from different model guidance. The left is from June 4th, 0 that wrong. The middle from June 4th, 12 that, and right from June 5th, 0 that wrong. So we noticed the PM in East Ontario by the most recent run was in kind of the most recent run tends to keep the PM further east. Otherwise, it's good agreement on potential significant smoke in East Ontario from June 5th afternoon to June 6th early morning. So this is guidance for June 6th afternoon, again from the three model runs. All three runs suggest smoke will be transported further west into central Southern Ontario. So there are some uncertainties as how far west the smoke will be transported, but given the favorable meteorological pattern, so OSPC issued special air quality statement SACS on June 5th morning for almost entire Southern Ontario, and this weather information also was treated in the mid-morning, June 5th. So what you see here are visibilities of Ottawa and Kingston. So you see the visibility was reduced dramatically on June 6th early morning to 2 statute miles. So that was very unusual due to wildfire smoke. So we can see firework models successfully capture the onset of this significant smoke event. Now let's take a look. The OSPC's forecast continue on June 6th early morning. So this time the focus is on the forecast of June 7th early morning. So remember from the time series, that's the second peak of PM. So again, from different model guidance. So this time, so you notice that the firework is not consistent. So the most recent run PM in East Ontario, that's from June 6th, there that was increased dramatically, almost doubled compared with the previous 2 old run. Because of this inconsistent guidance, so we still just kept AQHI 7 for East Ontario. So AQHI is the air quality health index. So it's a combination of the 3 pollutant, PM, N2, and ozone. One PM concentration reached 145 microgram per cubic meter, AQHI will be 7. And by June 6th afternoon, we have new guidance from June 6th, 12 that. This new run even give higher PM. The PM now this time PM in East Ontario in the this red 200 to 500 range. So it's very strong. In the afternoon forecast, we updated the AQHI for East Ontario to 8 and 9 for June 6th night, but we still kept AQGI 7 for June 7th morning. Well, you know the truth, you already know it's observed PM in Ottawa and Kingston reached historic high level, 500 above microgram per cubic meter. So our forecast is not high enough for the second peak. So we thought about some reason behind later, other than inconsistent model guidance, although the most recent one actually was right. But we are the PM level in Ontario, in East Ontario, it's kind of beyond our experience. We never saw such high PM due to wildfire smoke. But this is a good case to learn and to remember. Okay, one more day forecast on June 7th, early morning for June 8th forecast. So the top panels are from June 7th, 0 that run, the bottom from June 7th, 12 that, and the left panels are valid for June 8th early morning and the right valid for June 8th afternoon. So you see fireworks still forecast swath of dense smoke from Algonquin to Peterborough to Oshawa in the morning. In the afternoon, moved further west to Toronto, including Hamilton. And the new guidance had a reduced trend, but the PM still in a pink color, which still in a 100 to 200 range. By checking the flow pattern with the RDPS on the right side and the SPC, the mesoscale analysis from the left, the top for June 8th morning and the June 8th afternoon, the bottom. So although the northerly flow is less strong than June 7th, but it's still persistent to transport smoke from by northeasterly flow to northeast Ontario, then northern flow into southern Ontario. So well, this time we take the under performance of a previous day into the decision making. So this time our forecast went more aggressive. So we have forecast AQHI 8 for that dense smoke swaths from June 7th morning, and in the afternoon we update to 9. Well, the truth was this time PM was much overdone. So the model guidance in a 100 to 200 range, while was observed, show you in the table is 50 to 80 microgram per cubic meter. So well, SACs will still be necessary, but our forecast this time were too high. A quick summary of fireworks performance for this 4-day event. So it's well done for the smoke event from June 5th afternoon to June 6th afternoon, but the performance is not consistent from for the second peak PM, and much overdone for June 8th. So from this 4 days event, so the firework, the performance, actually it's firework is able to capture the onset of a significant smoke event, but it's not perfect. But it has better guidance on day 1. So okay, then my final slide for the risk communications during this event. It was the first time we include air quality in the Ontario Vigilance Bulletin. This is this OVB is produced daily for significant weather outlook, prepared for provincial emergency partners. So we also issued educational and situational awareness AQ tweets through the events, examples from June 6th and June 7th. And we got good support from Ontario Service for media coverage and also good stats from National Echo Team. During this event, the social media engagement was pretty good. We had the view volumes of Weather Office, WeatherCat app, and Twitter searched. We got a lot of likes and high view volume. And so for future severe wildfire events, so we had some improvement both from national side and from regional side. So do I still have time?
Oh, absolutely not.
Okay, so anyways, so we had good improvement for in the future in start this fire season for severe wildfire. That's my all my slides. Thank you. So if you have any questions I don't have time to answer, you can send email to me.
Thank you, Wei. So yeah, we will skip the question time for you, but we entering in a 10 minutes overall question. So if you have a question for Wei, feel free to put it in the chat, the Q&A of on the event Mobi. And I don't know if you know, but there's basically there's a delay of at least 30 seconds between what we see us who are actually on the Zoom and then the event Mobi. So sometimes the question comes after, and that's the case for a few people here. So okay. I'm gonna go on the event Mobi, and I take one question that has two. Oh, I see myself moving. I think it's Qing. It's about the radar. Someone said, I agree that ECC radar product available to the public need improvement. And someone else kind of mentioned that before. Rain and snow area are an easy addition, for example. Why not allow the public to see Doppler and dual pole data? We should not have to go to the sites like Radar Scope to do that. So you have an answer to that, Qing? Qing, are you there? Oh,
No, they left.
Oh, she left. Okay. Someone said I have another question. I think it was Robyn, is it?
Yeah, and I just direct messaged and sorry, I didn't know how to pronounce your name. Weiqing?
Yeah, yes, yeah.
Because I was wondering if you use the RAP smoke model in OSBC.
We did last year. So we compared with the American model, but you know what? So our actually firework was the best model for last year, wildfire smoke. So US model was good for the timing and the location, but much weaker. So that like PM level was much lower than our model. Yeah.
Interesting. Thanks. Good to know.
Okay, and I want to go back to Gordon with one question. Whoops. Okay. Just one moment. Someone said, okay, let me find it. Okay, have the draw data being used to create a historic climatology for Montreal? Is there a high resolution time series of temperature?
The answer is I'd have to get back to you on that because I'm not a climatologist, so I don't think there is any such thing yet because we're still working on getting all the data together. That's why.
Okay.
So we're hoping in the next year or two to finish because we've got an awful lot of data there. We're looking now at trying to finish the 19th century and then do decade by decade very systematically. At the beginning, anyone can enter data just based on whatever was open in terms of dates. They could pick dates. But now we're trying to be a little more systematic, and I'm having my students now only do things from the 19th century. So we'll fill that up and then move on decade by decade into the 20th century. So the 19th century will probably come first, but then afterwards we'll have to see.
Okay.
But we don't have any models that we've done.
Okay, that's good, Gordon. Keep this good work and keep coming back to the Congress to have some update on it.
My pleasure.
Okay. Chris Fogarty, relationship with NHE, unless it changed since I retire, I think it's the relationship with NHE is pretty good. But there is a question here. I think it's related to your presentation, Chris, too. Are you integrated new data-driven AI forecasts, such as GraphCast, to improve your hurricane track forecasts?
Yes, that's all new to me, that's for sure. All this AI stuff. I've heard of GraphCast and PanguWeather. These are, a couple of these new AI models, but myself, I don't know how to incorporate them into what we do now. Some of the forecasters on the team might be a little more familiar with them, but they're kind of like another model as far as from what I know. They're cast. They look very similar. The output's similar to some of the NWP.
Okay. A few more questions here. I think, Ching, it's another one. As a user of these new radars, the radar quality hasn't really changed as the velocity data is very noisy, making it difficult to assess thunderstorm. Secondly, the second trip echoes are numerous. Just wondering if there has been thought into changing the scan strategy to limit the second trip echoes and to create cleaner velocity scans, mainly using phase coding to obtain better velocity. And now that I finish to read that, I realize Ching is not there anymore, right? No, okay. Yeah, I have to switch from one to the other. Just looking the final question, if there's another one that was not covered. There would be another question for Ching. No, I guess that's about it. Thank you very much, all people. We reached actually 50 attendance. It was great.
Okay.
Few people
Super.
said that it was a really good presentation, and I agree with them. Thank you very much to the presenter. They keep on track on for the time, and then it was a very good presentation. And you're invited to the award ceremony that I will actually prepare a little bit myself for that because I'm part of it. But
Cool.
you're welcome to this presentation, to this award ceremony. It's a good way to actually, acknowledge the work that people have done, even if we don't know them. I think showing at the ceremony, it's a good way of thanking them to to their work. So thank you very much again. And then there's one more day left to the Congress. Tomorrow we're going to talk about AI. I know about this, so that will be interesting.
Okay.
So thank you very
Thank
much,
you.
all.
Thank you, guys.
Bye. Thank you.
And thank you,
Bye.
Zach, for your
Thank
support
you. Bye.
technically.
Thank you, everyone.
Thank you, Zach.
Thanks, Zach.
That went well, Zach.